Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. Right. We continue the discussion of the solutions of the problems that have appeared in the IIT JAM Mathematics 2024 examination. In this video, we discuss the solution of a problem from the section Real Analysis, and it is a NAT for 2 marks question. And this is question number 52. This is numerical answer type for 2 marks and the question number is 52. This question is suitable for all these examinations. And this question is particularly suitable for CSIR, NET and GATE aspirants. Right. The given question is the value of limit t tends to infinity in brackets log of t square plus 1 by t square whole inverse. The inverse is inverse of log of t square plus 1 by t square multiplied by integral 1 to pi t of sine square 5x sine square 5x by x dx bracket close. It is equal to, the answer is to be given rounded off to 2 decimal places. Right. Let's now discuss the solution of the problem in detail. Let capital L is equal to limit t tends to infinity of, in brackets, the inverse of log t square plus 1 by t square multiplied by integral 1 to pi t of sine square 5x by x. This is equal to limit t tends to infinity, the numerator is integral 1 to pi t of sine square 5x by x dx by log t square plus 1 by t square. That inverse we have written like this. For sine square 5x we write 1 minus cos 10x by 2. Right. Limit t tends to infinity integral 1 to pi t of 1 minus cos 10x by 2x, yes, dx by log of t square plus 1 by t square. Now we separate this as 1 by 2 complete taken out and limit t tends to infinity of integral 1 to pi t of 1 by x by log of t square plus 1 by t square minus, yes, this minus 1 by 2 limit t tends to infinity of the numerator integral 1 to pi t of cos 10x by x dx by log of t square plus 1 by t square. Right. Now, we 1 by 2 log t tends to infinity. Integral of 1 by x is log x. Log x is to be evaluated between the limits x is equal to 1 to pi t. So, log x when x is pi t, log pi t. When x is equal to 1, log 1 is 0. So, this is log pi t by logarithm of t square plus 1 by t square minus 1 by 2 cos 10x by x dx by logarithm of t square plus 1 by t square. Let's call this as the equation 1. Right. Now, we take the second limit. This limit t tends to infinity, integral 1 to pi t cos of 10x by x dx is integral 1 to infinity, as t, because t is tending to infinity, of cos 10x by x dx. We remember this is a improper integral which can be evaluated. In other words, we can say whether it is convergent or divergent using a test. So this integral dx is convergent using a famous test called Dirichlet test. And what is this Dirichlet test, and how we have applied this one, and how we said it is convergent, that I will explain to you at the end of this problem. So once we complete this problem, we take it. Integral 1 to infinity cos 10x by x dx is convergent. Convergent means it exists as a finite quantity, finite number. So therefore, let integral 1 to infinity cos 10x by x dx exists, and that is k, which is finite. So then limit t tends to infinity of the numerator 1 to pi t cos 10x by x dx is k, the finite quantity. The denominator we have written as log of t to the power of 4 plus 1 minus log of t square. This log of t square plus 1 by t square is, when you take the LCM here, log of t to the power of 4 plus 1 by t square, that is log of t to the power of 4 plus 1 minus log of t square. And this denominator also tends to 0 as t tends to infinity. Right. This is possible because the numerator is a finite quantity, by the denominator is tending to 0 as t tends to infinity. So this second term has gone. So we are left with only first term. Right. The second term is 0. So L will be equal to 1 by 2 limit t tends to infinity log pi t by log of t square plus 1 by t square. And that is equal to 1 by 2 log of limit t tends to infinity of log pi t by log of t to the power of 4 minus log of t square. Now, as t tends to infinity, it takes the form infinity by infinity form, which is an indeterminate form, and we evaluate this one using L'Hopital's rule, the so-called L'Hopital's rule. That is 1 by 2, limit t tends to infinity. The derivative of log pi t is 1 by pi t. Pi t with respect to t is pi. So pi by pi t by log of t to the power of 4 plus 1, 1 by t to the power of 4 plus 1. The derivative of t to the power of 4 plus 1 is 4t cube, minus log of t square, derivative is 1 by t square, and the derivative of t square is 2t. Simplified and written here. Now, taken the LCM in the denominator, and further simplification will give you 1 by 2 limit t tends to infinity of t to the power of 4 plus 1 by 2t to the power of 4 minus 2. In the denominator, a 2 is taken common. So 1 by 2 into 1 by 2 into limit t tends to infinity of t to the power of 4 plus 1 by t to the power of 4 minus 1, and this will be 1. So 1 by 4 into 1, that is 1 by 4, and that will be 0.25 because it is to be rounded off to 2 decimal places. So thus the answer to this question is 1 by 4, that is 0.25. Right. That is the detailed discussion of the solution of the given problem. Right. I remember. Yes. I will explain to you the Dirichlet test, and using the Dirichlet test, how that integral, is convergent. That means it converges to a finite number. Right. Right. This is Dirichlet test. We have two functions. Let f, g are two functions from the interval a to infinity closed at a to r, real valued function on this domain, both of the functions, such that the first condition f is decreasing and f of t tends to 0 as t tends to infinity. Second, g is continuous, second function. There exists a m such that mod of integral a to x g of t dt is less than or equal to m. It is bounded for all x greater than a. Then integral a to infinity, the product f of t g of t dt converges, means it exists, and that will be a finite number L. Now we will show that integral 1 to infinity cos 10x by x with respect to x is convergent. Now the given integral is written as integral 1 to infinity f of x g of f of x multiplied by g of x with respect to x, where f of x is 1 by x and g of x is cos 10x. And first condition, f of x is 1 by x is decreasing in 1 to infinity. Yes, it is decreasing. And f of x is equal to 1 by x tends to 0 as x tends to infinity. So the first condition is satisfied. Second condition, g of x is cos 10x, is a continuous function everywhere. So also continuous on the interval 1 to infinity closed at 1, and modulus of integral 1 to x g of t dt is equal to modulus of integral 1 to x g of 10 t dt, that's equal to, after integration, sin 10t you will get mod of 1 by 10, after integration you will get sin 10t to be evaluated between the limits t is equal to 1 to x. For the upper limit 1 by 10 modulus sin 10x minus for the lower limit sin t, sin 10 when t is 1. Right. We estimate 1 by 10, it is less than or equal to 1 by 10, mod of a minus b is equal to mod a plus mod b. So 1 by 10 into, in brackets, mod of sin 10x plus mod of sin 10. And sin function modulus will give you is always less than or equal to 1. The first one is less than or equal to 1, the second one less than or equal to 1. So therefore it is 2 by 10, less than or equal to. 2 by 10 means 1 by 5. Thus we got m, and it is true for all x greater than 1. Right. So the second condition is also satisfied. So we use Dirichlet theorem, Dirichlet test. This is the integral 1 to infinity cos 10x by x dx is convergent. Converges. Convergent means it exists, and it exists as a finite number, let us say L, and we have continued in the last slides. Thus, this is the Dirichlet test. I hope that you have learned now, and this is how we have applied to the integral that is arising in the main question. So that is what I wanted to tell you, and I am sure that you have understood the solution of this problem, and you have understood what is Dirichlet test and how we have applied to the given integral, given improper integral. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.